All right, welcome to part 2 of your 3-6 notes, reflections in the square root family. So the first half of the notes, we just wanted to get you guys familiar with the root function, how it's graphed. Do some regular translation, left, right, up, down with it, like we've done the first couple days with lines and also the quadratic family. And then add on one more transformation, which is a reflection. So when we talk about reflection graphically, we're talking about over an axis. So reflect over the x or reflect over the y. I think when you first start thinking about it, a good way to think about it is just as a single coordinate. And as you do the reflection, what changes? Drawing a reflection is very easy. It's a counting idea. So you can count from the axis you're trying to reflect over and then count that same distance on the other side and you've done the reflection. So if this is my original point and I want to reflect it and I count to the x-axis, reflect it over the x-axis, that's 1 to the x-axis and then 1 on the other side, and there's my point. You know, pick that grid up off the screen and fold it in half along the x-axis, and those 2 points should actually line up perfectly. There's your reflection, a mirror image. On the y-axis, same thing, count to the y-axis, so count 1, 2, and then count 2 on the other side, and there shows up your point. Same idea, if I pick this grid up off the screen and I fold it in half perfectly on the y-axis, those 2 points would line up with each other. Now, it's kind of useful to think about what happened to the coordinates as you did that reflection. If you do the reflection over the x-axis, you notice the sign on the y value changed. So it went from positive 1 to negative 1. In a more of a general way of thinking about it, or writing it, that's how we describe transformation. So when I reflect over, how we describe a reflection. When I reflect over the x-axis, I actually make the function, which is like making y negative. So reflect over the x, make y negative. You notice how when you reflected over the y-axis, the change was actually on the sign change was on the x value. So change the sign on x, reflect over the y. So reflection over the y-axis is a sign change on x. And there's the basic connection to, simply just counting and how we would have presented to you kind of just in general. So we're going to work through the general idea a little bit more to see if you guys pick up on that. And with a piecewise graph, that's always a good way to start doing any kind of transformation. And then go specifically to the root function to finish it up. Remember, piecewise being a combination of graphs, so this is a combination of multiple lines. But piecewise are nice for counting purposes when you want to count a reflection, count to an axis. Again, getting back to the idea of which one is which, so make the function negative, reflect over the x-axis, make the x value negative, reflect over the y-axis. So I'm going to show you these 2 graphs. I'm going to pop them up here one at a time. This is our reflection over the x-axis. And if I was doing this from scratch and didn't have a pop-up, obviously, I would just take the black graph, which is my original, and I would just start counting, just like it says here. You want to make it easy, just count. So from that point right there, I would count 1 to the x and then a 1 on the other side. I'd count 4 to the x-axis and then 4 on the other side and so on. This last point, for example, 6 to the x-axis and 6 on the other side. And then again, if I was to pick this up off the screen and fold it in half on the x-axis, the blue and the black would match up perfectly. One would overlay the other. The red being our reflection over the y-axis, let's pop that one up and have a look. So again, now they overlap each other, which sometimes when you're drawing and your reflected graph overlaps your original, you might start to visually start to kind of get a little hazy, but again, think about it as just counting. So, if I'm starting with this point here and I count to the y-axis 2, then I count 2 on the other side. There you go. And if in whatever direction, count the opposite way, right? So whatever side, count to the opposite side. So if I'm counting on this side of the y-axis, a count of 1, then a count of 1 takes me to the other side, and so on. You can transfer all those points. If we did want to do it coordinate, we can look at the coordinates and say, is that still going on? It most definitely is, right? So if you check this coordinate out, that is 2, 1. Over here, it's negative 2, 1. The sign change was on the x value, and that causes a reflection over the y. If you check out the blue coordinate in the black, these two, negative 2, 1, and this is negative 2, negative 1. The sign changed on the y value, which is what caused reflection over the x-axis. Okay, that's kind of a quick look, but getting that counting idea down so we can do that well, and then let's now go to the root function and see how it works. So now we got is the actual graph in front of you. So we're going a little bit different direction. We're saying visually can identify what reflection I have. Now, to be able to do that, you really would want to visualize where is the parent function. Where is y equals the square root of x? So I'm going to pop that one up so we can have a look. And also over here. And you know, once that's sitting there, I think it's pretty obvious which one is which. I mean, clearly the left side is a reflection over the x, and the right side graph is a reflection over the y. But can you attach these things correctly? Now it says which one they are, but let's say I didn't have those there. You know, like these weren't sitting on the page. And you just had these, could you place them correctly? And you know, today of course we want you to get the idea down, so we're not trying to hide the ideas from you, but which one is which, or reflection over the x-axis would be this graph. So this is how I would write the equation of that graph. Again, when you reflect over the x, you make the entire function negative. Reflection over the y-axis, which this would be the equation for this graph. And when you reflect over the y-axis, you make the x value negative. Okay. Let's actually do a little bit more with this, then we'll wrap it up on our notes for 3.6. So now again, I've got the shifting going on. I want you guys to be able to write the equation based on what you see. And a good way to start this problem is always, you know, identify the vertex. The vertex being that kind of start of our graph, right? So here we're at 2, -2. Over here we are at -4, 3. Remembering that the vertex is the hk. So the format that I'm working off of now is that y is equal to x minus h under the root plus k. So really we're just going to insert those things, but the other thing that's got to be inserted is now we don't just have left, right, up, down, we have a reflection. And you know, like any graph, when you have to look at a graph that's been transformed, it's always good to think about, you know, where did this graph start from? What's the parent? Where is the parent? So visually, there's my parent. If I look at the left side graph, it looks to me like there's been a reflection over the x-axis, and then a movement to get me to that spot. On the other hand, if I look at the right side graph, it looks like there's been a reflection over the y-axis, and then a movement that got me to that spot. That movement is, of course, taken care of by the vertex. So when you go to write, what we're going to do is we're going to drop in h and k, like we've been doing for the last couple of days, and then we're going to attach that negative in the right spot. Remind yourself of which is which. All right, so I'm going to go to writing tool here for a second, just write and fill in some stuff. So let's start with my vertex and my h and k. It's a right movement. So remember, it goes x minus whatever your h is. In this case, my h is 2. Plug it in, and then down, so -2. And then I got a reflection going on here over the x-axis, and when we reflect over the x-axis, we make the entire function negative, so we throw our negative out front. So there's reflection over the x, right, and down. I'm doing my -4, 3. Now again, keep reminding yourself when you drop in the x minus h, it's x minus whatever your h is. So minus a -4 means it becomes plus. And I'm hoping by now, third day of talking about this, that you guys know that a left movement is plus in a set of parentheses. And then my 3 is an up, so +3 on the outside. And then my negative, well, it's been reflected over the y-axis, and when I reflect over the y-axis, I make the x value negative. This is a little unique. We got to use this set of parentheses because we're going to drop that negative out front. So I know normally, like I said earlier on, that the root itself acts as a grouping symbol, but because we have to put the reflection, if we didn't, then it wouldn't really be an accurate shift. So the thing is, how does that affect this? So now what we're going to do is, to make this correct, how we're going to write it to finish it up, is drop that parenthesis off and distribute the negative in. Now the first thing a bunch of you guys are going to say is, wait a minute, -4, isn't that supposed to be to the right? Because I feel like over here, -2, I'm going to the right, and all of a sudden it's -4. But you got to think about it as, here's where this problem began. It was left with a reflection applied, and when I apply the reflection or distribute it in, I've got this. So here's actually the correct way to write it. A little bit of a twist, but again, practicing, you guys will get used to that. Okay, a couple other things here, or I should say the last thing is solving. So you notice in the last set of notes we did quadratic, we did solving because we had x squared and we're trying to solve for x. And the way to get rid of that x squared was to take the square root. Well, this is the opposite idea. These equations have roots in them. And what is the opposite operation of taking a square root? Well, it's to square it. So the first thing we're going to want to do is get rid of our root by squaring. So this one's kind of a good starter problem. It doesn't take a whole lot to get going. Now what you do to one side of the equation, you got to do the other. So we know that from the quadratic notes, but that's just kind of algebra true generally. Right? Square this side, I got to square this side. And then when you do that, x plus 3 is equal to 25, and just keep solving. The solving part, once you get rid of the root, is simple enough. We're talking about some algebra 1 here. So subtract 3 from both sides, and x is equal to 22. 22. One of the things you guys will have to do with root equations is we want you to check your answers. It is possible that sometimes during the course of doing this work that you create a situation, or you create some things that really didn't exist to begin with because of squaring, or you add something to the problem, and you might get a solution that doesn't actually produce a true statement. So just check it quick. It doesn't take very long, like 2 seconds, right? Plug that 22 back in. 22 plus 3 is 25. Square root of 25 is equal to 5, and check. I've just proven that answer works. So square both sides, or just squaring gets rid of the root. Now, in a problem like this where there's kind of a little more stuff attached to the root, what you want to make sure you do is clean this stuff off. So get the 25 out of there, get the negative out of there. In other words, isolate the root. You don't want to go squaring until you've got the root sitting by itself. And again, these steps of like getting the root by itself, basic algebra kind of stuff. So subtract 25 to the other side to start. Negative times any kind of expression, we would divide through by a negative, get rid of it. So now I divided through by a negative. Now the root sits alone, and you see now this problem appears like this one did. This is where I want to be before I start squaring, and then go ahead and square both sides. Okay, and then from there just finish the solving, right? So x minus 2 is equal to 64. Add 2 to both sides, and x is 66. And again, what I should do is check that. So what I'll do is go back quick and just plug it in. 66 minus 2 is 64. The square root of 64 is 8. And 25 minus 8 is 17. And check. Got it. Okay, and that's going to do it for our notes for 3.6.